Okay, is it okay? Okay, now we will start. What is the stream classes? Okay, just I will take the book to show you. Okay, first, just we go for a differences. What is the difference between C and C plus plus? C is a fixed, okay, and one more thing is C is extensible. What makes C++ extensible and C++ fixed? What is these things? First we will take the simple example. Okay, you know the syntax of C. If you want to get some what characters, integers, you have to place it in some formats: printf, percentage d, and x and y. Similarly, for character, percentage c, string, percentages, whatever, there are lots of things. Okay, you have to handle it from the C. But in C++ it is overloaded by the IO library. Okay, streams library. What they have done in C, in you can take the input as I. Okay, just write it I. For character, just take from the scene also. Okay, it's compatible, and you will print the entire sentence what you want in C++ for a C out. These are input and output streams. Then, so these are called as fixed streams. C++ is fixed and flexible. We will define our own tags. That's nothing but a extension. You will extend the C++ programming till you want. That's the overloading, operator overloading. What do you want? Just do your programming and add it. That's the simple thing. Then what is the meaning of stream? Stream is nothing but a synchronous byte. Okay, synchronous byte transmission. If the byte transmission is done from memory to IO, is called as output stream, and IO to memory is called as input stream. IO means keyboards, mouse. There are different types of IOs. Okay, these are the input streams, these are the output streams. There are three types of IO operations. First, what is the IO operations? IO operations are mostly bottlenecked. Bottleneck means there are large number of strings and processor is processing the strings in minimum numbers. Means the processor has some restrictions to handle the strings. So the processor is processing minimum strings. So it is get bottlenecked. Two types of IO operations are there. One is formatted IO operations, second is unformatted IO operations. What do you mean by formatted IO operations and what do you mean by unformatted IO operations? Formatted IO operations, it is related to allocation memory, allocating a memory, handling some specific, giving some specific surrounding to execute that particular program. Like an integer, you if you have declared an integer I, then you will allocate some memory for that integer I. Okay, and you are doing some programming. While program is executing, it will allocate some memory, it will give some predefined surrounding to them, and it's somewhat tedious, time consuming. Okay, but unformatted strings are nothing but your printf, scanf. These are somewhat unformatted streams. You can't format it, and you do not require some surrounding for them. So they are fast, flexible. These are the things. Two types of IOs. One is high level IO, low level IO. As I explained, high level IO is nothing but formatted, and low level IO is nothing but unformatted. These are the two strings. Okay, now we are going for layers of streams. There are streams. First, what is the streaming? Day-to-day example. What is the streaming? Just YouTube is one kind of streaming. It is streaming some data, and it will including some data. Okay, streaming is required. While you go for a streaming, there is requirement of a buffer. It is static buffer or dynamic buffer. You will allocate it or compiler will allocate it. What is the day-to-day example? YouTube. Okay, it will stream. What is the meaning of streaming? It will buffering the content and it will directly playing the contents. That is nothing but the streaming. Okay, that's these are the streamings. There, these streaming are has some architecture. Have these have three layers. First is formatting, second is transport, and third is normally our what levels, locals or levels. Okay, communications. Formatting is related to my your computer IO screens, okay, output screens, whatever it may be. Okay, and formatted is deal with that, and programming is dealing with the files, input output operations, and communication link is there. That is nothing but the locals. Okay, next we will go for some in depth. Programming is there. You will write the program, you will take a buffer, and a external file or a device is there. External device will give you some data or some linking, and that data you will take in your program, and that you will execute it. Okay, and gives the output. But whichever data is given by the internet or somewhere or something devices, that is not in proper format, that is in different format, like 264.75. If you want, you have taken the 264.75 or something, it will loaded in C++ as a floating point. Okay, it has some architecture 875.11 something architecture is there, floating point architecture, and it C++ store the data in that architectural form. Okay, so for taking that data we require a buffer because we are dealing with the stream. Okay, yeah, are you getting my points? Then, first, what is the external device? External device is related to the external things, internet, extranet, uh, file is there, output file is means outsourcing file, which is given to you as an input. Okay, first you will take that file, you will arrange it in a buffered manner. You will entire file is put it in a buffer, because we will require so much file handling, means dealing with the data synchronously, so that if you are directly dealt with the IO file, it will require more number of handshaking. To reduce that more number of handshaking, we are using the buffer. We will put maximum file into the buffer and pass it to the programmer. Okay, after, if the programmer is executing that buffer, we are transmitting the data simultaneously. This process is going simultaneously, transmission of data is there. Okay, next thing is, are you getting my points? Because this is imaginary point, I don't want to draw the things. It's a virtual things, you have to imagine the things. Okay, here I have noted the points and I am explaining that points. Okay, so because we require for explanation some synchronous data transmission is required, so I have taken the points and I am talking about these points. Okay, then these files are external files, these are in different formats. We want to change that format because they have their own data types, they have their own programming methods, they have their own data signaling elements. So we want to change the data elements, so we go for first encoding. While transmitting the data into the buffer, we encode that data and then transmit it to the buffer. Then buffer is now it's converted in our format, whichever is required for our execution. Then that formatting buffered is given to the program, and program gives the or done the formatting, execute that program, and it will shows the output in the monitor or display devices, and that is nothing but a formatting instruction. Okay. Mm, why we are using the buffer. As I told there to you that fast processing data is required. If we dealt with the directly to the IO, we will require more number of handshaking. To reduce that number, we are gone for buffer. Okay, now we are doing, now I am telling about architecture. What is the architecture of iOS? IO stream, O stream, and S stream. These are the three streams: I stream, S stream, O stream. I stream is deal with the input things, and out stream, O stream is deal with the output stream. These two are inherited in a single file called as IO stream, input output stream. Okay, are you getting my points? Uh, iOS is the main class, and he deals with the all the types of operations. We have inherited its input in iStream, S stream for a streaming input, and O stream it's a output. So we have combined input stream and output stream in IO stream. Then furthermore, there are two types of streaming inputs: input file stream and output file stream. Input file stream is inherited from input stream, and output file stream is inherited from output stream. These are related to file operations. We want to do a file operations. Are you getting my point? iOS is main class, which is super class. We inherit the iOS class in three types. First is iStream, second is SStream, and third is OStream. iStream is dealing with the input streaming things. OStream is deal with the output streaming things, and SStream is dealt with the streaming input and output things. Okay, these iStream and OStream is combined in iOStream, so we include iOStream directly. These operations are related to the normally our C++, but if we want to include a file, we go for file input stream and file output stream. This file input stream is inherited from iStream, file output stream is inherited from OStream, and we combine these two in a F-stream. And iOS is also directly inherited to the F-stream, so we include F-stream only for dealing with the IO operations. Okay, and there is one more thing: file buffer. File buffer is dealt with the S stream, streaming inputs, because streaming is required a buffer, and we are allocating it buffer, or if we don't allocate the buffer, the compiler will allocate S stream, compiler will allocate the buffer to the S stream. Okay, next, fstream .h is the main header file. It is uh, inherited from the iStream, file input stream, file output stream. Okay, these two are inherited. Some functions of these two are inherited in the fstream. Fstream is also deal with the opening file, closing file is open. Set mode, set mode is related to the, it is binary mode or character mode, whatever mode you have you will select, that's related to mode. Set buffer, if you want to allocate a buffering size, we will go for set buffer. RD buffer, RD buffer is related to the, we are taking the pointer that where is the means you, we want to go through the data in the buffer, we require some pointer addressing modes, so RD is a address of the buffer. Okay, are you getting my points? Then next is FD, file descriptor. There are some unique descriptors allocated while executing the program, that is nothing but a file descriptor. We will go for a file descriptor. This is a unique ID given by the compiler. Okay, then namespace. Here comes the big deal. Namespace, what is the meaning of namespace? Why will require a namespace? Namespace is nothing but we are allocating some region to execute that particular file. Okay, are you getting my points? Executing that particular file in a particular region. I want to access some particular variable from particular region. I have to allocate that particular region. Okay, it is too difficult to imagine, just I will clear some imagining doubts. Okay, you have taken the two programs, and in that two programs there are the two files. Okay, and in these two files there is the function of display in these two files. I have done a program to display a function in file 1 and display a function in file 2. Okay, there are two display functions, and if I included these two display functions in the main file, then if I call to that function, it will allocate memory to 1, memory to 2, but it will gives a error that redeclaration of the functions have been done in the program, because it don't know, the C++ don't know about these files, that there is a display file, there is another one display function is there. They don't know, it will directly arise a error. If it is a small file we can change the names, but it is a two huge files, it is means 2000 lines of code, 3000 lines of code, it will gives the problem. What type of problem? Because you don't know the different names of a function, and you don't want to go through different names of a function, there is no time to deal with that uh, these things. So will allocate some region to that program. There are some programs given to by the directly company, because we don't know the specific names, specific functions, we allocate a namespace to that program, and means we are allocating that region to that program, and we will access that region whenever we require. That is the same simple thing why we are gone for namespace. Okay, thank you for listening this lecture. Okay, have a